Open the Robo Analyzer, please. Okay. We from the experiment 8 until 12, we gradually work on simulation of the robot arm. Now, experiment 11 is industrial robot arm application using the American-made robot ABB IRB-120. We will simulate this robot. This is the actual robot, the actual appearance. This is the simulation. Okay. And then you will be using, in your theory, this will be used for the calculation of the composite homogeneous transformation. So I'm not going to discuss this in detail. It will be in the theory. Now, calculating for the final position of the point coordinates. This is our PXYZ. When you go back to the chapter 3, this is our PXYZ, and this is our PUBW, and this is our R. But for the robot, this is a composite homogeneous transformation. PP. Now, how are we going to determine the equation? You will use this formula, 0Ti. In order to determine the homogeneous transformation matrix, if you have 6 degrees of freedom, this will become 0 to 6. So it can be any number of composites. If it is 9 degrees of freedom, this is 0 to 9. 0 to 1, 1 to 2, multiplied by 2 to 3, and so on. And it is summarized. This is the summary of the equation. This will be tackled in theory. Now we go on the procedure. In the procedure, so you open the Robo Analyzer. So let me open first the Robo Analyzer. Now you will not create a robot here as what you did before. Here you will use the available robot. So just go to follow the steps. It says there, open virtual. So where is that? It is here, open virtual. Click that one. And then you are told to select the ABB, but it is already by default. Then click check to update. Then you tabulate the values. This is the value. These are the values of the HTM. Tabulate that one. Here, that's what you will tabulate in number 2. This is before applying position. Just go to the Cartesian control. You have here the same HTM here. This is the HTM, the composite of the commercial robot ABB. Now what next? You input step 3 in the Cartesian control. You are now here. Click that one. Input the final position. Now you will apply final position here. So you input 100. And then 0, 0. And how many steps it will move? It will be 100 steps. Now see what happened to the robot. Watch out. After we put our target here, listen, our target is to move the robot to the final position 100, 0, 0. Now see what happened to the robot. Start. What happened to the robot? Anybody? What happened to the robot? It is moving forward to the final position. Now, this is the result. What will be this is now the final position. What happened to the final position? This is now the final position. Okay. You will write the HTM in step 4 and tabulate number 5. This is the final position. Where are you now? Are you now in step 5? This is the value of your step 5. That's the after you put the new position and you run it, you will have the final position. Now, step 6. Calculate. Click home. Click home, meaning you click home to go back to the normal position. Back to normal position. You multiply this. You multiply this with this for the step 6. That's the formula. You multiply this one to get the final. This is calculation. You compare the simulation with the calculation. That's the formula. So multiply this with the HTM. And you should have the result the same with after you run this. After you run, you should have a result the same here and here. Calculate. Click home. This is the value of the XYZ. Multiply that with the HTM. And then 7, you compare the results. You got the same answer? Not yet? You, the calculation and simulation will give you the same answer. This is the result of simulation. And then this is the result of your simulation. And the calculation is multiply this with this. You should derive the same answer. Did you get the same results? Anybody, group? How about you here? You get the same results? You got the same? You got the same? The instruction is very clear, 6. Read number 6 carefully. Step 6, read carefully. You calculate the matrix in step 2 by multiplying it with the result with the relative value position or value relative position in step 3. The result will be the n vector frame. Group 1. You got the answer? Not yet. You got? What is it? It is clear in number 6. Read carefully number 6. Step 6. Number 1. Step 2, this is before. That's before. That's after. What's this? Coming to college, no ball pen? You get the same. This one should be the same. Okay.
Almost.
Okay, Lino. Very good. Bro. How about you here? You got the correct answer? Okay, how about the Munir, Muhammad Munir, you got correct? Ah, this is default. Multiply the default. Multiply with the position you want to place. And what will be the result of the n vector? That's the result. That's the result. Now let's proceed to the B. Next activity B. Huh? When you are done in B, A, don't forget to click home because this is B now. Click home for the robot position. Are you now in B? Okay. When you are in B, you do step by step. So you go to click record. In the record, so click record. Then you click start. You will record the your activity here. Start. Then you go to Cartesian control tab. You input categorically means one by one. Start with column 1. You will be entering here 100. It will have 100 steps. Keep it 100 steps. The meaning of steps here is the robot will move 100 steps. Start. Wait until finish. Wait until finish. Don't forget to click home, home. Before you start, click home. And then column 2, type 0, type minus 150, and 0, then click start again. Wait until finish. Then you carry on for the others. You will see how the robot will respond. Carry on until finish. I think you're right. This observe. You're right to observation on the right part.
Assignment to give us about the eight and the moment and sell it. The paper and this.
We do.
The paper.
We do. Where you will submit?
And that is,
Are you sure, huh?
yeah, I think getting.
Okay, next. It's something so far, we have. Right on.
Okay, you got this? This shows a basic 3D printing, how this robot will do the 3D printing, how it will follow the line. So this is an example to give you the idea. Now, when you are done, click stop. You go to record and stop. Then click export. It will save a file, Excel file, CSV file. Go to the desktop, experiment 11. It's a CSV file. Now you can click home. You can click home. Are you now done? You can now use that file to program this robot. Click browse file, open the Excel file, and play. It's a CSV file, Excel.
So before
It's
reset,
huh?
reset.
Home, click home, not reset, home. what's the inside of that experiment, that file? It will say the values. Did you see this in the Excel file? There are 600 values there. 100. Now these values are used when you have a program. This will be used in the program to run it. So this file will read, the program will read this file and tell the robot where to move. So this is how to simulate. Have you seen the file inside? There are 600 files there. That's it.